This message is brought to you by Spirion. The data privacy revolution is the new age of protecting what matters most. Automatically and persistently discover and classify sensitive data with the most accurate solution on the planet. Understand the data within the context of your business and then take actions to control that data so you can operate with minimal friction and comply with the laws and regulations built to protect the personal data privacy of individuals across the globe. This is Spirion, protecting what matters most. Visit them on the web at securityweekly.com/Spirion. The question is simple. Have any of the systems on my network been compromised? The answer is harder than it should be. Enter AI Hunter. Active Countermeasures has automated and streamlined techniques used by the best pen testers and threat hunters in the industry to create AI Hunter, a network threat hunting solution that does the first pass of a hunt for you to identify systems that are most likely to be compromised and scores the results on a scale from 0 to 100. You can then research those systems in depth with AI Hunter. Focus your valuable time on the systems that need your expertise with AI Hunter. Sign up for a personal demo today at securityweekly.com/ACM. Welcome back, everyone, to Paul's Security Weekly. Our next webcast is February 13th. And if you want to know how you can capture packets from the cloud, well, from the cloud or in the cloud to the cloud, anyway, if you want to be able to do the network packet capture thing, but on your cloud services, you should attend this webcast. Even if you don't want to learn it, you should learn it anyway, because at some point you're going to have to. Sri Sundaralingam, he's the Vice President of Product and Solutions Marketing at ExtraHop, will discuss how the cloud native network detection and response works. And Matt Alderman and I will be presenting. And if you're going to follow along with this technical segment, what's really cool about this webcast is it basically lets you attach a sniffer to your VPC. Now, there's a lot of little nuances in there that we'll go into in the webcast, but that's essentially what it means, which I thought was pretty awesome. So securityweekly.com, hit the webcast drop-down menu for registration.
And who wouldn't want a sniffer on their VPC?
Right? Everyone needs a sniffer on their VPC. Speaking of VPCs, for whatever reason, there are reasons why I wanted to learn AWS. Lots of reasons. One, our application that we use for publishing all of the shows and a lot of other business stuff, it turns out more and more, is being built in AWS. There's already components in AWS. It has so many different services, and arguably the largest cloud computing platform. So I'm like, well, I'll start there in terms of learning it. Now, I think like many of us, I had learned aspects or pockets of AWS over the years, like, oh, that was a really cool article, or I just talked to my friend Tyler at Black Hat about Lambda functions and the best, like how not to use them and how to use them, right? And you may have components of your project or tests that you do in AWS. What I decided to do early this year is, well, like I really just want to dig in and actually start learning it. And I didn't like take a training class or even like watch videos. I want to learn it the hacker way because I'm impatient.
You start clicking buttons.
Kind of go start clicking.
What does this do?
What does this AWS CLI thing do if I upload this JSON file, right? I don't suggest that you learn it that way for a couple of reasons.
The bill.
One, it's super frustrating. And two is the bill, right? Two is the bill. Because what's interesting about AWS, it makes it really easy to spin things up, but not so easy to take things down.
What do you mean
right?
I have 10,000 servers running?
Right? Yeah. And so a lot of us, have been there. So this is part one. There was way too much ground to cover in what I have been working on in various components. So I tried to distill it down and focus on the security aspect of securing your AWS deployments and specifically containers. So the other reason I'm doing this is because I'm working with containers, because Container Security Day is coming up. And I had this like old crufty service out there that I'm like, that should really be in containers, and that would make a good project. So both part of daily work and segment for the show. So my goals. I wanted to create secure Docker containers that allowed me to deploy open source apps. Now, admittedly, I thought this first goal was going to be easy because I'm like, certainly people have done this before. But what they published was nowhere close to what I wanted to accomplish actually in production. And that's what we're finding. And I think many of us have found this too, right? Is you want to learn how to do something. There's some great tutorials online. but that's not production. Like, that's missing so many different aspects of what it means to actually run a service in production. Now, as I said before, I wanted to host this in AWS to learn some of the AWS services. I wanted to then also create a pipeline. I mean, my background largely is systems administration. And if these are going to be services that I have to maintain, putting my sysadmin hat on, I want it to be as easy as possible. I want to be able to build new versions, test them, and if it passed the test, I want to deploy them into production. I don't want to get into some of the legacy sysadmin things that come along with physical servers, virtual machines, or even cloud infrastructure aspects. So my first kind of realization in this project was something I've already alluded to, is that basically the internet lies a lot or doesn't have good advice, or both. And when you're trying to accomplish goals such as Docker containers and such, and working with various configurations, there were some solutions that gave me some hints. And I will publish everything that I have open. I gotta get ready to make my Git repository public. But I stole some concepts from other projects, but there was no project that even got me somewhat close to what I wanted to accomplish. So other people's basically Docker images that they had created. So there are the official base operating system Docker images. There's the kind of official, actually there's an official media wiki Docker images, right? And that's the application I'm working with, is MediaWiki. It's a PHP application. So much of the work I've done here, you could extend to a lot of different PHP applications, probably even other languages and frameworks as well, although there's some certain nuances with MediaWiki specifically and PHP. So their official images really didn't get me there. And then you get into things like, like Mattermost, for example, which I think is pretty great software. But when they give you a cloud deployment, it's like, do this Elastic Beanstalk. And I'm like, well, that's just taking it way too cookie cutter for me. I've got customizations and security that I want to build in. Largely, those other projects leave it out. So if you're going to start down this path and you're serious about taking applications, whether open source or ones that you're creating yourself, applications you're developing, with applications you're developing, largely you're going to build your own containers anyway. I'm leaning towards that and recommending that you build your own containers to wrap open source applications. Because what's out there is, I don't want to say it's crap. I mean, that's not fair, because people did put in work, but it's custom to them and not up to my security specifications. And so building your own Docker images, if you're familiar with Linux, should be, I mean, it's pretty easy. There's some nuances there, but good Linux background helps. And then you take your images that you've built, you put it in your own repository, and then that sets you up for deploying into the cloud. So there was this kind of whole realization I had to have that it's not just going to be as easy as, pull from node :8, and now I've got a node application running. It's not that straightforward with this project in particular. So that's my first piece of advice, is create this diagram first, not at the end. Figure out what you want to do and plan on building your own images. And Tyler and I were talking earlier, and that's a very important point, because you're going to want to validate whatever you're pulling down from the internet. The base images, the software you're pulling down, that all needs to be validated, scanned for integrity, scanned for security, configured securely, and check that your configuration is secure. So what I did was I created, if this was my test environment, these would actually, the database wouldn't be an RDS, but these would be 3 separate containers. A lot of the examples that I saw combined MediaWiki, and I see this with WordPress and other PHP applications. They put the web server and the application server, which in this case is PHP FPM, on the same container. That makes your container very, very large and doesn't give you the benefits of microservices, right? If one goes down, then everything is going down. If you need to update one, then everything needs to be updated. So they call it microservices, so that you break it apart into smaller pieces. So that's what I did. So I built an Nginx container. Now, fortunately, I had examples to pull from for building Nginx, and that's pretty straightforward. Obviously, that's going to listen on port 80 and 443. Then I took out And this was some work, right? So like I had to break apart packages to give just Nginx what it needed and give just PHP FPM with MediaWiki what it needed to run as a standalone container. And when you make a request to the web server, if it's for a PHP file, Nginx has that functionality where it passes off that connection over a port. Now, when they're on the same system, it's a Unix socket. When I broke them apart, it had to go over port 9000 off to the application server. So Flask will work very similarly, right? Other application frameworks will work very similarly. So,
hey, quick question as an aside: is 9000 becoming a common port?
It is the default port that PHP FPM will listen on.
Okay.
So that's just what I set it to. I conceivably you could set that to any port you wanted.
Actually, more relevant question than Jeff's, because man, I love you, Jeff.
Wow.
It's relevant to me because I saw it today somewhere else, maybe in my day job, and I was just curious. So,
Well, yeah, okay.
Joff, you have a question, my friend.
Carry on dissing me.
I do have a question, and that is, I understand, I well and truly understand that Docker has internal network bridging. It has some defaults. It also has the ability to create your own custom networks. The traffic that you have in this image between your Nginx SSL cert MWM instance and your backend PHP FPM MediaWiki stuff, I am making the assumption that is running on a separate bridge network with probably some private IP, kind of like a point-to-point network. Is that a correct assumption?
Yeah, it's a great point, Joff. So there are multiple ways to configure it that way, or separate it off into a separate network. Right now, I've got it deployed on the same network, and here's why. When I build this container, it runs PHP FPM as a non-root user and only listens on this port. So, like right now, I didn't prioritize separating it off. Conceivably, you should, just in case a larger shop, when there's more than just one developer, someone pushes something in that opens up SSH on that system or whatever, right? You're right, Jeff. It should be on a separate network.
So that the question I'm hoping illustrates the point that microservices also allows you to extend into microservices that are across these separate bridge networks that the Docker containers allow you to loop up and give you that flexibility.
Yeah, this is running on in my example, it's running on one Docker bridge network. So they are, yes, on that same Docker network. Correct.
It's wicked cool, is what it is.
It's cool. Yeah, it is cool. And there's other ways to do that as well, especially when you get into AWS and likely the other cloud providers. They've all got different ways to do. Like I think it's Amazon. In AWS, they have AWS VPC as a networking mode, which does networking like differently than Docker. I didn't read into it because I was like, I'm familiar with the Docker bridge, and that's going to work for my application.
Well, what I really like about it is very many years ago, I used to create a data center model that was very well secured, that did this level of network segmentation, using MPLS clouds across, actual virtual hosts. But what you've got is the same model that's giving you microservices architecture within the application containers. And you don't. It's not nearly as heavyweight. You've got this beautiful the model that kind of gives you that what I would call microflows of traffic between your architecture components, which is
You can also control this traffic within the VPC and create multiple subnets and put them on different subnets. I haven't done that yet. I think it'd be a fun exercise, right?
I'd like to play. If I have time, with scaling out horizontally too with this kind of model, just to see, how you can replicate and scale out nicely, and I'm sure you can. Yeah.
So then, of course, the application server talks to the database server. Locally, that's a container that I build on the fly. In Amazon's cloud, it's an RDS instance. Which right now lives in the VPC. Again, to Joff's point, right? There's better ways to do the networking. To me, this was all kind of a similar level of exposure and risk. So the other nice part about RDS, is it does encrypt the database for you. It's kind of just like a check. Actually, it is, in fact, a checkbox in there, which is nice, encrypting the data at rest. Of course, you still have to deal with the database credentials, which we'll get to. Now, one thing I won't go into a whole lot of detail is how I did the storage architecture, because if you've ever had to deal with storage and microservices, you probably like have a lot less hair right now. It's very gray because it's a gigantic pain. It's probably an entire segment that there are some security aspects to it, but largely, let's just say I created some Docker volumes and I have to share those Docker volumes between containers for this particular application. For example, my images directory, my app server needs to be able to have an image uploaded to it. That app server then needs to write that image to the images directory. However, when a user comes in with a browser and just wants to browse the page, the web server needs to read that image to serve that image to the user. So I had to do some shared volumes, which got some pretty tricky. And there are some permissions things which I'll show you. Also, I have not gotten to truly securing my certs. I've just put them in a separate volume and put my certs in that volume for now, which is not the best way to do it. You should use Certificate Manager within AWS to secure your certificates. But I had, up to today, I had not gotten to that point. So basically, I just and if you can find it on the internet. It's really like you put up a dummy container that mounts that volume. You copy your certs into it or your data into it, and then you're off to the races. Not the best way to do that. Okay, so when we talk about protecting credentials, this is one thing that we've talked about in the show in the past, and I'm actually really excited that I get to show how this looks first in a local build environment on the right way to protect your credentials. And this is also very specific to this application. So the first thing that's very critical in the lower left-hand corner is in this particular example, this is a local build environment without a secrets manager. If you're doing a like really true production enterprise application, or even just a larger application, or you just care about security more than I have up to this point, you've got a secrets vault. You can use AWS Secrets Manager, Systems Manager within AWS has this functionality with a parameter store, and HashiCorp makes a vault. Conjure makes an open source vault. So I definitely recommend a vault. However, those of us that aren't developing enterprise level or enterprise grade applications are going to need to put some containers together and put an application, and we might have secrets. So I wanted to offer my take on that right now. So important, your git ignore ignores your .env file. Your .env file sets up environment variables that by default, every time you initiate Docker Compose, it will read from a .env file. So my .env file contains my passwords, right? My root user for the database, which by default, when the database container gets created, gets injected into that container, and my user password, username and password for the MediaWiki database user, which needs to be on the app container and needs to get set inside the database. So I put those in my .env file and then just make sure I never check that file into my Git repository. Then inside of my Docker Compose file, I set those environment variables values to arguments. It's an important distinction. These are not environment variables that will live inside of my containers. These are just arguments that are read from my local environment into my Compose. So when Compose then calls the Docker file to build the container, those arguments get passed over, and I declare them as arguments at the top of my Docker file. Then my little hack to get that inside of the place I need it inside of my container. Now, unfortunately, MediaWiki stores these, just like WordPress, right? Stores the database username and password and connection information in a clear text file that sits somewhere on the app server and or web server. You have both in the same, right? So rather than have that file be moved around, because then that file could be potentially put up to Git or use any other number of hacks. What I do is I read it from my environment at build time, and then I write it directly into the file using sed. Now, it's going to live in this file no matter how it gets there, right? It's going to live in clear text because that's how the app wants you to do it. I have not looked into how you might protect that. Have you looked into that? Because you've done some WordPress stuff in the past. Are there ways to somehow encrypt, use a key system to encrypt it inside the configuration file for WordPress or MediaWiki?
I don't think so. I don't think I've seen too much of that. And clearly, even if you are able to do that, the key's still going to have to sit there somewhere. So if somebody's at that point, then they're going to have what they need to pull it apart.
So my goal was to just keep it out of as many local files as possible and keep it out of as many environment variables as possible and just grab it and write it right into the file and be done.
I think
that was my solution.
Joff was trying to jump in.
Joff.
Oh, I just I was a little confused. I understand that you've got a .env file with your credentials, which is awesome, and obviously you're going to put it in your .gitignore, so it does not get uploaded to your Git repo. And God bless you for that, because I've pen tested with creds.
It's common. Right? That's what I was trying to avoid, Joff.
Yeah, that's 100%. But I thought you had a reference, Paul, to some sort of vaulting solution.
Yes.
And I'm missing that in this picture. Can you kind of explain that a little bit more?
Sure. So a portable vaulting solution would be HashiCorp's Vault. So you can tie that into your build process and production process, where your processes will check out a key in a secure manner from the vault to be used inside your application. So Conjure was bought by CyberArk, and they have an open source version. HashiCorp, I think, is slightly, no offense to my friends at CyberArk, but I think HashiCorp is a little more popular in terms of an open source vaulting application. And then when you move into the cloud, I'm sure Google and Microsoft have it in their clouds, but in AWS, there's two different ways to protect or to have a key store. In fact, I'll show you one right here. The first one that I'll cover is part of AWS Systems Manager. It is the parameter store functionality of Systems Manager. And in there, you can create a secure parameter that you can then include in your other AWS services. And it has a list of supported services. Not every service. And then AWS also has Secrets Manager, which is just another vault that's available in the cloud. So I decided to use Parameter Store as part of Systems Manager to store my credential. What's interesting is there's two different ways to store a credential in there. One is just you're storing the credential and you can see it right in your browser and it's not encrypting it. The method that I chose that actually worked by default, which was kind of weird because I haven't read about it yet, but it encrypts the parameter, the value of your key in KMS, the key management system within AWS. So you can see
I was waiting
till
you got.
Yeah,
I was waiting till you got to that KMS. Okay.
Yeah. So
you do have an option there if you want to, but a local file version, if you're developing off cloud,
yes,
is a perfectly reasonable way to do things.
Yeah, and I think the use case too is if you're developing an application and you want it to be portable to different clouds and environments, you want to use something like a HashiCorp Vault that gets built along with your application so it's more portable, right? In this case, I wanted to put it in AWS, so I was just going to use their credential stores. And there's
Have you investigated the HashiCorp Vault at all at this point, or just?
I have, yeah. I've read it, read some of their posts on like how to implement it. It's not very straightforward, but it's definitely on my project list for this year.
Got it.
Yeah. So then when you configure that, then you go into your container definition when you create your container in ECS, which again, I don't really go into in this segment either, but there's a whole, you need a cluster and a service and a task, and then your container lives within the task lives in the service, and the service lives in the cluster. So it's like a whole vernacular you have to learn for ECS. But when you get to the point where you're defining your containers in ECS, you just put for the value from is what you use. So instead of your environment variable being a value, in ECS you say my value from, and then you give it your ARN string, which points to your parameter. And you can define that in the interface, which is largely how I was kind of getting stuff configured. But you can also define your configuration in a JSON file, and that's what it looks like. The JSON file is definitely the way to go and where I'm moving. Because in the interface, you gotta, like, if you gotta recreate all this config, you gotta recopy and paste it, and you can't script it, right? So you definitely want to move to the JSON file using the AWS CLI to build out your environments and do that. And that'll be in the next phase of my project. So
I think M and 10 asterisk is not the strongest password you could have used.
No, certainly not. Well, I didn't want to put my passwords out there. The nice part about this, though, what it gives you, I think both in my local version and in this version, it makes it really easy to change the password, right? In my local version, since I'm building the database as a container every time I do my build, I could change the value in my .env file. When I build up my entire environment, I now have a new password in the database and in my application, which is awesome, right? So maybe I accidentally checked it into Git, and getting anything out of Git is a huge pain in the ass. I would just change it, and sure, you can see my password in Git, Joff, if you're doing a pen test, right? But it's not valid for anything.
Right.
Ideally in dev, I'll just write a script to randomly change that at build time every time.
So I had a question.
Yes.
It's been a while since I played with AWS, but I remember there when you got to the shell level, you were able to walk all the variables that are available. Are these credential variables available in that same manner? Because I'm thinking that Docker's if you could have a script to extract environment variables by hacking it. Anyway,
yes. Go ahead. I'm not sure. I haven't looked at the resulting image, Lee, to see if I could pull it out of the image. I believe it gets written into the container at runtime from AWS. Conceivably, that would live inside of the image if you were able to pull it apart, I think.
But otherwise, you can't get it. So I have to get the running image with the value in it.
Correct.
In order to win.
Correct. Yeah, because
right, and the other danger would be not leaving some sort of backdoor into the running image, right? Like an SSH session, because then bad things would happen.
Correct. I do have. Well, I'll show you how I get into that.
But that's just admin trick number 72.
Yeah.
Right. The other thing that you'll notice when you start working with containers, or even if you have been working with containers for a while, people love to run their containers as root. They don't drop their permissions down to a regular user. Now, I think one of the reasons they don't do that is because it breaks stuff. Yep. And specifically for me, what that broke, because I was trying to be a good security person, right? Because I'm trying to show people how to do things securely. One of the things that broke was when you create, not you, but when Docker or ECS, right, ECS specifically creates a volume for the first time. If I've defined a volume and it doesn't yet exist in ECS, what it's going to do is if that directory exists inside the container, it inherits whatever permissions those are. So since I ran my build as the root user to get everything installed, then I dropped down to my lower privileged user. When I then referenced the images volume, the images volume was owned by root, and I couldn't write to it, which means I can't upload images in MediaWiki. So what I had to do was make sure I added my chown script, command here to include images to fix that problem. So you will run into a few snafus. A lot of other scripts will not take into account that you're not running as root and break things. Like a lot of things just assume your containers are running as root because so many people do it. Don't do that. It's really bad.
Right. So what you're saying is treat that container as if it were a standalone Unix system and secure it the same way.
Correct. Correct. Yep. I mean, treat it almost like a user on the system, basically.
Yep.
So, and conversely, because the container is written as root, you're setting only the areas that the web user can write, so they can't go do nefarious things outside that space.
That's correct, Lee. That's correct. Yeah, and a lot of these PHP applications suffer from that, especially ones that take uploads like WordPress and MediaWiki. Patrick knows. We've done incident response together on that exact issue, actually. So yeah, file permissions definitely matter. I only set the ones that it needs write access to according to the MediaWiki documentation.
Then the rest is effectively read-only.
Yep.
Which really comes back to what is old is new again, right? I mean, it's the same principles. It's just at a container level rather than an operating system level.
Correct. Which also brings us to running trusted images, which is also a mistake that people make. Just like libraries in Python and Node and other languages can be either Trojaned or taken over by attackers or backdoored, as can packages in any Linux distribution. So can Docker images that you're pulling down. And so when this is just my build bash script, and you should set this environment variable so that what it'll do, Docker content trust separated by underscores equals 1, will only pull signed images. So if the image is not signed, it will not pull it. So it's somewhat of a measure to make sure you're not pulling down some random person's Docker image that might be tainted, right? It's not perfect, but anyway.
So when you build your image on top, are you also signing it?
I should be. It's a great point, Lee. When I looked at this, I said, well, when I'm like you said, when I'm building my own image, I should be signing it. And there's some extra steps in the build process in order for me to do that, to put it up in my own registry. I do, and I don't think I go through it in this technical segment, but I do apply permissions and rules to my registry so that you have to be a particular user with a particular IAM role in AWS in order to pull images out of the ECR, Elastic Container Registry. And also, I only grant other roles the ability to pull images out of the registry that need to. So like my ECS task role, I had to specifically grant it permission to pull the images out of my registry.
Because the reason I was asking is I had a conversation the other day with some of our developers, and they were talking about not only using signed image, but configuring it so that their environment, in this case their Kubernetes, would only launch signed images, so that if I slipped an unsigned image in there or something illicit, it wouldn't run.
Right. Correct. So that is trusted images. Up-to-date versions of all the components is very important. One of the things that it was a huge pain in the ass about things like MediaWiki, right, is I got to go for this build process. If you're to do the MediaWiki update manually, which I've done many, 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 many times, you have to go pull the source from MediaWiki as a tarball. And installing it is basically just untarring that tarball to plop over your PHP files and then copy back stuff that you need to copy back, which is a huge pain in the butt. Extensions are also installed in a similar way. I basically pull a tarball, I extract the contents of that tarball into the extensions directory. And if I want to update it, I got to go get the new tarball and extract it, test it with the latest version of MediaWiki, and there might be incompatibilities. So what I do now that I have this in containers, every time I build a container, I go pull, the latest stable version, which I control in an environment, a variable in my Docker file, I should say, and I go pull the latest version of some of the extensions. And the extensions are distributed in all kinds of different ways. And this URL may 404, my Docker build may fail. That's fine. When we get later in the tech segment, I'll talk about how I want to build a CI/CD pipeline for spitting out open source software inside of configurations like this. It'll tell me, hey, it's broken, right? Like the version changed, or they moved repositories, or that version's end of life and no longer available, whatever the case may be. Cool. Now I got to go in, I fix it, fix this URL, fix the MediaWiki version, do my build. Oh, hey, it builds. Let me do some testing. Now I can push it out. So it gave me a repeatable process to always be updating to the latest software. Right now, manually run tests. You can script those and then be able to push out my open source software, which is way better than how you would traditionally do it. So
yeah, I mean, this gives you the DevOps aspect immediately. But so Paul. What am I wondering? I'm wondering here is, why didn't you integrate that directly into a Docker container itself? I mean, it looks like a post-build script to me.
It's a great point, Joff. I actually say that in my to-do. This will now become part of a multi-stage build. So the first build, right, you pull down, it doesn't matter what image you pull down. Debian Slim, right, which is what I'm using, install curl, then pull down all your software. Then when you go to your next stage, just copy the files from your first stage, which doesn't carry over any of the environment from the previous stage.
Right.
Yep. That's a much better way to do it. And it gives you a cleaner image.
I realize we're catching you at a moment in time. So yeah, I mean, I'm being a perfectionist like all of us.
No, and I wanted to get that in there, but it means massive restructuring of my Docker file and testing, which I didn't have time for, but it's totally doable. Yep.
So just because I'm tired, it's been a long day. What are you doing with the 512 SHA?
That is just the hash of that MediaWiki version, which I define in environment variables at the top. So if you need to update MediaWiki, it's a good question, Lee. I would say that the latest version is now 1.34.1, and that tarball has a different hash. I would go into my Docker file, and I would update the version number and update the hash, and then run my build.
Got it.
Probably some better ways or to more automate that,
It's
process,
still cool.
right? But yeah, it's definitely better than the way I was trying to do it before, right?
I mean, that's the thing with Docker. There's like 1,000 ways to do anything, which is, that's awesome. You got tons of flexibility.
Yeah. There's a really cool project that I wanted to mention. It's called HeyDoll Lint. Does anyone use this for their Docker files? Anyone use this before?
Tell us about it.
So it's an open source project, and it's basically just like a bunch of regex that parses through your Docker file and identifies potential vulnerabilities or things that you can improve upon. Right? It'll flag the from. It'll flag all kinds. It's actually, if you go to that GitHub page, it lists out everything that it checks for. This is a great thing to build into your CI/CD pipeline, right? Especially if you're building your own custom images, and it makes recommendations. Now, some of the ones in here I haven't looked into, obviously, because it's flagging them, and it's making some recommendations. You can also have it ignore certain recommendations, like if you don't really want to pin versions of every single one of your packages. I mean, if you do, props to you. Like that's pretty awesome. But you can say ignore DL3008 and don't flag on it anymore. So it's a pretty cool checker. I've used it to actually improve, like to get to where I'm at. I've used HeyDoll Lint, and it just runs as a Docker container, and it's documented on their GitHub. It's a really cool project. I like it. You should use it.
Cool.
Now, even though I have so the image that I start with is Debian Buster Slim. It's the latest version of Debian. Well, the unstable one is Debian 11, but it's the latest stable version of Debian. It is the Slim image, so it's a much smaller image. I don't use Alpine because it doesn't use libc, and I'm afraid at some point that's going to be a dependency that I need for something. And there's also articles I've read about the performance of Alpine in production that aren't so great. I think for smaller projects and testing, Alpine is fine. But I prefer to use Debian for my production images. And the way I found that was, for example, when like Docker Hub builds a node image for you to download, it's what it uses to build that node image. It uses Debian Buster Slim. So I would look at what environments you're building, then see what the base Docker images are using as its base for that, and kind of go off that. So we could do a whole segment about Alpine versus Debian versus other distros. But I've used the smallest base image that I like that I could find. And so I'm not just saying like from PHP. And so I did a segment on ESW where I compared this, right? I did from node:8 to build a node container. And then I did from Debian Buster Slim, and I manually installed, through the Docker file, installed all of the node packages. From node:8 had 23,000 vulnerabilities. From Debian Buster Slim, when I was done, had 43 vulnerabilities that were all informational level. Of the 23,000, there were several criticals and highs. So in this project, this I believe is my PHP application server image. I enabled a scan on push in my Amazon registry. So when I push images into my Amazon ECR, it will automatically go scan those for vulnerabilities. Which, I mean, there's lots of tools to do that. I'm not sure if Amazon built their own or is OEMing something. But so it scans my image. Now, this is the latest image that I can pull down. And you can see it flags curl as a vulnerability. Even though I've removed curl, when you go through my Docker file, you'll see that MediaWiki requires PHP curl, which I think is still installing this as a dependency. So, but pretty cool that Amazon can give you a report on what vulnerabilities you might have.
I really have nothing to contribute to this conversation. I'm just curious, is there a Debian version called Buster Move?
No, there is not. Debian 11 is called something different. I don't remember what the code name is for that. Ironically enough, this curl vulnerability is fixed in Debian 11, which is the current unstable branch.
So Paul, I love the idea of scanning on push back up the repo, and it's been a highly endorsed thing, but it's interesting to me that there's enough software components out there with enough vulnerabilities that may not be critical. They may only be contextually relevant to your particular implementation, and so the scans tend to be a little overly zealous. I think they point out everything that's possibly wrong, and yet in your code, you may not actually be exercising that particular part of the library, and it may not actually be an issue. So it's kind of a weird thing to me.
It is often the case, Joff. Like when I look at this, these vulnerabilities here, I'm like, well, I'm not really using that library in that way.
Exactly.
Like with Python, right? You could be importing a library using one piece of functionality, but the vulnerability is in a completely different function and piece of part of the code in that library, and you're not using that. So therefore, you're not vulnerable, right? On the surface, I mean, maybe, but.
But also, aren't some of the vulnerabilities mitigated by the fact they're not running essentially in a read-write container? It's functionally read-only.
My file systems are not all read-only. You can deploy it that way, Lee, to have a read-only file system. Okay. And that would mitigate some of these.
Read mostly?
Potentially mitigate some of these vulnerabilities. But like Joff was saying, it's hard to say. It's hard to.
Oh yeah, well,
it's hard to gauge your risk.
I'd be tempted to say with this container, ignore the curl vulnerability. Let's look for stuff that's not that.
Right, and I think that commercial systems give you a lot more control over. Yes, I know I'm going to have all these things that you're flagging, but right now my application, doesn't apply to these, so just ignore them for now, right? And maybe ignore them for a certain period of time.
And it strikes me that in a commercial release, you probably would have advice out to your customer to say, yes, this is a flagged CVE, but my product only exercises this part of the code. It should not be impacted, and spell it out for people.
Exactly.
And my kind of assessment of this is if you want to get rid of these vulnerabilities, you've got to build your own Linux distribution inside of containers.
That's actually where I was going to go next. You've totally avoided having to piece together package by package the minimum you need.
Right.
And probably save a lot of time and money by using a pretty damn good fit.
Right. And that's what I've done. Because you can, I forget what you call it in your from statement, but there is like a ground zero base Docker image that has basically nothing in it, right? And then essentially you've got to download components and you've got to build your own distro that will make up the Docker image and make sure you compile everything together and put it together so it doesn't have these vulnerabilities. I was not that advantageous, to be honest with you.
You know what? The beautiful thing is that all of it is there for the taking, and you can make these choices,
right?
Which just puts us in a completely different world because, if you go back to the idea of one big fat OS distribution and you were either up to date or you were not. Mm-hmm. Now, this is much more granular. You're actually a Docker image. You've got specific components. You can actually be very targeted at a microservices level. That's a completely different animal. The threat model looks completely different. The entire assessment model looks different. I mean, it's very, very different.
And I think that the defense and kind of response aspects of this are really what makes it more secure. Yes, I may have some insecure configurations and components. However, I can very easily build those and test them and make changes and push out a new release in a very, very expedient manner. And I think that's really the strength and power of a CI/CD pipeline and DevOps is now that I've got it in this config, I'm still working to get rid of this curl vulnerability, right? So maybe I'll get there, maybe I won't. But the point you're making, Geoff, right, is I have those tools at my disposal to detect and make changes and push something new out.
Yeah, you have agility that you never had before.
Right.
I mean,
Now, one thing I remember building Linux images is it was like as you're picking what's in there, it's tempted to do the someday I'll need this, and you just wind up with a crap load of extra junk you never touch. Does this help with that temptation, or does that require personal discipline on your part to just stay to absolutely what you know you need?
No, it definitely, it makes it easier for you to do that. I mean, if you're not paying attention to it, you can build gigantic images and include a bunch of stuff you don't need, and some people do that. I don't recommend it because you have that control. And where you run into some issues with that is if you get a little too greedy is how you're removing things, you might break your application, right? So the curl thing is a great example, right? I install curl, and I use it to install stuff at build time. I then have code in my Docker file that removes curl and all of its dependencies. However, if PHP curl has that same dependency, and I'm basically shortcutting or circumventing the apt package management, saying, no, I don't care what you say. I want you to remove all the dependencies for curl, even if something else depends on it. Screw you, because I know what I'm doing. Then when you hit that piece of code in MediaWiki that needed PHP curl and it doesn't work, don't be surprised. So you can't shoot yourself in the foot that way.
So I would like, and I know Paul was thinking this, I'm just going to say it for him, go back to the microservices architecture diagram, and you will avoid that way of thinking just by dedicating the right component of your overall solution in the right place in your design. It will fall out naturally that you won't overbuild if you've done your thinking correctly.
Correct. And the other thing is it's easy to iterate and test. I mean, okay, I can go make some changes. I can remove some packages and run it and build it and see if it works, right? That doesn't take very long to do that. And it doesn't take very long to reverse that either. Oops, I broke something. Let me put it back, right? Because I'm checking all of my configuration files into Git. So if I screw up, I can always go back, right?
This is cool.
So some AWS deployment notes, stuff to do first. Many of you that have worked with AWS probably already knew everything that's on the slide. However, I needed to learn the proper way to set up VPCs and all this stuff. Now, I do want to caution you, and Geoff, this goes to the BHIS research in AWS and some of the vulnerabilities you uncovered. You can, and in fact, if you look at Amazon's own getting started guide for ECS and other people's guides to ECS, they're like, just go in and do this and accept the defaults. What that does, that creates a VPC for you, that creates a subnet for you, that sets up all of your rules for you. I don't recommend you do it that way. If you're really going to go all in any cloud provider, spend the time and build out all of your components in the back end. In AWS, that starts with your VPC, right? So I created one specifically to deploy my open source applications. Then that I had really nothing else. So I had to create subnets, internet gateways, route tables, network ACLs, and security groups. And I got it wrong, like a lot, right? So I had to then delete all of those and start over, right? Because sometimes you run into the situation you can't fix it. You got to delete it all and start over until I got it right. And then I reached a point where I couldn't get to anything in my VPC. And my rules were right because you set rules in your security group is where you add your air quotes firewall rules. And I'm like, it's that. I'm like, what? I just forgot to add a default route in my route table, which is funny because people like Marcin was like, I'm getting to know this AWS thing. He's like, but I don't know networking. I'm like, well, I think I know networking. I've done some networking. And I'm like, oh, missing default route. I've been there before, right? Now it's just in the cloud. So same problem, but in your cloud architecture. So make sure you add a default route to your route table. Otherwise, the instances within your VPC won't be able to know how to get back to you when you connect to it.
I think there's one other thing you're doing here, but you may not have mentioned. It looks like you're using SSH keys, not passwords, for authentication.
Yes. So that's a great point, Lee. I left that out. That is another thing you have to create when you create all this infrastructure in the cloud. You can create multiple. You have to create keys to get into stuff. And some of the things you create in here will say which key do you want authorized to connect to these particular services or instances. Correct.
So does that imply then, Paul, that you are using the AWS's I forgot their Vault solution, but are you storing your private keys in their solution as well?
Yeah. I forget where it lives in there. I forgot to put a screenshot of that in here.
Okay, well, it's a yes.
Yes, it's AWS. Yeah, the SSH key is in the AWS configuration screen for your key. Is it your key store? So I forget what it's called in AWS.
You can store just your public key, but for some stuff you need to have a public-private key pair.
Correct.
So.
Correct.
Yeah.
Yes. There's the public-private key pair is stored in AWS, and then you download it, and then you do SSH.
How long you been working on this presentation?
I did these slides today in about an hour, and I've been working.
Okay, but the work before that,
working in AWS for probably over a month, maybe.
Yeah.
Okay.
Yeah, is when I started.
Cool.
So my hack around like getting access to stuff in my VPC, because there's stuff I need to do in there that I don't know how to configure it in a better way right now. Is I'm like, you know what? For now, I'm like, I've got this VPC. I'm like, what would I do in the past? I'm like, I'd put a jump server in there. I'm like, well, shit, this is the cloud. I can spin up a new instance just by doing a few clicks. So I spun up a Debian instance, I stuck it in my VPC, and I'm using that as my jump server. I'm not saying that's the best way to do it. I don't know moving forward if I will stick around with that particular solution. But for right now, for where I'm at in my level of knowledge of AWS, I'm like, that's what I'm going for right now. Obviously, this is a VPC. You can VPN tunnel it back into your network. Likely a much better solution. But I just wanted to have a jump server in there so I could get some stuff done. Specifically, there was database operations and just things that I'm spinning up in my VPC. And I'm like, did I get my network ACLs right? Did I get my routes right? Is it actually listening? Does it have the right policies in the right roles so that ECS can connect to RDS? I had a lot of those questions because I had never done that before. So I put a jump server in there. What was interesting is when I built the RDS database in the same VPC, right, wrong, or indifferent. Again, there's lots of ways to do this. In PyCharm, has a database interface. If you get the commercial version of PyCharm, and it allows you to see all the tables, make queries, import, export. If you're working with a lot of databases, especially in production, it makes things go like 10 times faster working with databases. But I'm like, my RDS instance does not have a public IP. I'm like, but I have a jump server. So I go into PyCharm, I give it the credentials to my jump server, and PyCharm automatically uses that as an SSH tunnel and connects to my database, which is pretty awesome. I thought it was pretty cool. A little hack for now. Obviously, there's better ways.
Hey, Paul, so all this aside, right, you've done a lot of Amazon work, but if for average developer that does not want to spend the money, could they spin up their own, Linux box on their own ESX server and just do all this stuff local? Yeah,
it's actually, it was easier for me, right, because I'm still learning the AWS stuff, but if you're doing containerizing, I hate using it as a verb, but if you're containerizing an application that you've written or an open source application and you just want to run it locally, you can certainly use Docker Compose. I would probably recommend doing your own Kubernetes and running it locally. The reason I didn't do Kubernetes in AWS's cloud is because it's a separate app that isn't tied into hardly anything in AWS's cloud. So you really can't use most of the features in AWS if you're using Amazon's hosted Kubernetes. If I were to do it locally, Joff, I would probably script some stuff with Python, maybe Ansible using Docker Compose, or doing my own Kubernetes deployment locally.
Is there an Amazon equivalent to Kubernetes that does work?
It's ECS, is what they built as kind of a competitive type product.
But they put Kubernetes out there just to frustrate you?
Just to make people happy. Okay. I mean, I guess if you do need to host Kubernetes and you don't need a bunch of AWS services, you could do that.
Gotcha.
So it'd be a fun talk, which I'm giving myself things to do here, to take a local deployment that you've got and talk about how do I take my local deployment and then scale it out into AWS using those features.
Oh, and when you use that word scalable, Joff, I haven't even scratched the surface between load balancers. Then you can have services in different availability zones. I mean, it's
crazy.
Amazing. I mean, if this particular app didn't need to be like that scalable just to run our wiki, right? But if you've got higher demands in terms of availability and uptime, and you've got money to pay Amazon, you can certainly scale all that stuff out.
I am interested. I have got some artificial intelligence code that I may turn that into a presentation.
The other thing that was interesting in AWS was roles, right? By default, when ECS runs, the default role that it takes on inside of AWS is this ECS task execution role. If I had to do it again, I'd probably create my own custom role and attach these policies to it, because I kind of assumed that Amazon would take care of some of that stuff for you, but it turns out it really didn't. So pretty much all of the policies you can see attached here are points in my process where I had to stop and troubleshoot, and I was getting an error message that basically this AWS service can't talk to this AWS service. And I'm like, oh, dummy, that's because the ECS task role, for example, didn't have access to the EC2 container registry, right? Which probably shouldn't be full access. I probably need to tune that down a little bit. It also needed access to the database. It needed access to the systems manager to get access to the parameter store to pull that credential for my database, right? So each one of these I had to attach the policy. They're probably, they are a little looser than I'd like right now. And there's probably better ways to do that in terms of writing that JSON directly rather than going in the interface and clicking on policies. So, yeah. You'll have to play with IAM roles as well, which is fun, or not. So my to-do, where I'm at now with this project, really I want to be able to separate builds for dev testing and production and build a CI/CD pipeline. Again, pulls down all the latest software, builds it, tests it, sends me notifications, run some automated tests, maybe some manual tests. And the reason I say manual tests in this process is because it's not my application, it's really someone else's open source application, right? And it's a very big one. When a MediaWiki extension throws some error, I don't know what that's going to be. Like, I don't know how to test that weird condition that might happen if an extension's not working, right? We have an extension that embeds video. Maybe the videos aren't embedding. I'd have to write a test for that. I mean, I could write unit tests. I could be spending a lot of time writing unit tests. Or I could just have it build it and say, hey, I built a new version because it was a new version of MediaWiki. Here's the URL for it. And I go there and manually inspect it. And I go, yeah, it's good. Go ahead and push it to production kind of thing is where I'd like to get to. For that, I'll probably look at one of two ways. I think Tyler, I don't know if Tyler's still there, but he was telling me that there's a Python library for AWS CLI that you can use to script some stuff. You can use Ansible. You can use code deploy, code pipeline, and code build in tandem with each other to basically build out a CI/CD pipeline directly in AWS. Obviously, there's costs associated with that, but that is one way. Or you can script things as well with the AWS CLI. And moving more towards me not having to go into the AWS GUI to deploy things or change things. All of that can happen via JSON files, which I thought I had an example of. I did have an example of that in there. And that's, I think, a much better way to management. So that gets into, you can build all of this infrastructure, and many people are doing this, Terraform, cloud transformation. Basically, you build all this infrastructure as code rather than manually, me showing you how to click around in the GUI or run AWS CLI commands individually. You can basically script all this out with, code libraries that exist for Python, as well as describing what you want to create in JSON configuration files. I need to put in a certificate manager for SSL certs. There's a service in AWS that will help you manage your SSL certificates, which is separate from managing the secrets inside your application. I do want to put in sysdig. There are open source versions of sysdig and sysdig inspect. So sysdig is a agent or like library thing you would build into every single one of your containers. It uses, I believe, BPF to gain visibility and telemetry about what's going on inside your container. And then it sends that data to a sysdig inspect system that puts it in a web interface for you. So basically, if people are trying to hack into your containers or you're troubleshooting performance or whatever, this would give you insights into it. And Sysdig has some open source versions for that, which is really cool. Logging is another thing. If I glossed over it in here, it's likely another segment to talk about how CloudWatch is doing all of the logging within AWS. I write all of my logs in my containers to standard out, which allows CloudWatch to pick up on them. And that was a configuration that there was a template available for it. So in the web interface for AWS, I can see my logs. But obviously, I want to be able to collect those and send those to a centralized analysis engine. And then, of course, monitor costs, very important, and make adjustments because you can conceivably get a really big bill once this happens. Now, speaking of costs, I don't know what it's going to cost inside of ECS. I have to go run some models and monitor it. For the RDS instance, I used MariaDB, and I used a pretty small instance, and it estimated about $27 a month, which I thought wasn't bad. Less than what I'm paying to host my database, which is way larger than I need it to be because it used to host multiple databases. Now it's just one. And so I'm migrating infrastructure off of our other provider, Linode, is who it happens to be. So,
are you able to spin services up and down and as need provides, or are you still looking to figure that out?
Yeah, that's correct. That's something that I definitely want to script, right? Especially for development environments. I'm toying with, do I have a development server locally that spins that stuff up? Or do I script it so it spins it up, sends me an email, and then after a certain period of time, if I don't do something, maybe it spins it down, right? Because you don't want to leave, every time you create an environment inside of AWS like this, there's a cost, right?
So,
Go ahead.
I was just going to say, that's the ops part of the equation, right?
Right.
Is to have the appropriate monitoring in place and to grow the deployment only when needed, right? Only when the demand warrants it.
Correct.
And shrink it back down to some minimal footprint when the demand shrinks back down.
Yeah,
right?
There are elastic options in there, right? Obviously, the word elastic is in all of their vernacular. So the containers, you define the base amount of memory, and then you can configure like if it can grow beyond that space. The same thing with CPU. Same thing with the database. You can do the same thing. You can kind of define if you want it to be able to grow or not, and monitor all of that is the important thing, right?
Yeah, and so that interesting part of that is this is where microservices architecture actually grows into its, no pun intended, but grows into its own maturity when you have the ability to scale up, scale out, and you've architected it correctly. You can have an amazing serviceability that with static deployed virtual servers before you just couldn't do.
Yeah. So our publishing app has a much better use case for that. When we upload a video, right now I've got internal containers that take that video and do the conversions, right? Same thing for images. In AWS, that's a perfect use case for only when we upload a video and it needs to be converted, send it off to this container or this service, spin it up, do your conversions, write it out to S3, and then spin it down, right? That's a great use case for that.
Great use case, yeah.
Cool.
Good stuff, Paul. Good presentation.
Thank you. Any questions?
Thank you.
Probably the one thing I was wondering is when you started this whole thing, you said it took about a month. What was your prior experience with AWS? Was it you had never logged into AWS before, or you had?
No, I did have some experience. So I had labs at previous jobs that were in AWS. I had a developer that just one day woke up and put our database for our production publishing app in RDS. So I had to learn that component, especially after that person left. I went to a different job, right? So I've done other types of those things in AWS. I experimented with S3, but again, it was like very small pockets of like, I have to do this for this task and just work my way through this thing, right? It was never, I want to take this multi-component application that is running in production today and build a production-ready environment in AWS where it's not in AWS today. So this will run our wiki. When you go to wiki.securityweekly.com, it'll be running on this infrastructure in the next month or so, I would imagine, that I'll spin down everything I've got in Linode and move it all over into AWS.
Hey, so Paul, I've got a question on, so having taken that journey as an information security professional, what are your biggest fears and what are the biggest opportunities for us from an assessment perspective, given the technology experience you've had and the challenges that you've had to overcome as you're implementing this?
It's a great question, Joff. One, I would say it's the kind of permissions inside of AWS that are just different, right? Like, I've been doing networking and systems, I'm old now, for a while. And I get into AWS and I'm like, how do I do that and make that talk to that? And then, as we know, you err on the side of, well, just make it wide open. And my fear is those going into AWS, especially for the first time and building out their infrastructure, have it kind of loose and open to get it to work, and it's going to take multiple iterations. In fact, Marcin, our developer, said that to me today. He's like, you're like, final. I laid out like 3 phases. He's like, phase 4 is you going back in and then applying more security configuration to what you've already done based on what you've learned. I'm like, you're absolutely right.
Sounds like you're putting...
Because it's hard to do that the first time through.
Sounds like you're putting in any rules.
Hopefully not. Hopefully not. I mean, I did attach certain policies to my role. I did specifically write firewall rules in the air quotes firewall rules in my subnet group. Subnet group, I think, is where you do that in AWS.
It was on one of your slides where you put them.
Yeah, I didn't put what the firewall rules were, but yeah, you still have to write firewall rules.
Right.
So that's a concern, Joff, is just the way you do that initial architecture is kind of scary, right? And all of the different permissions. The other thing is, whether you're doing the first time or it's growing, is if you use a cookie cutter like Elastic Beanstalk or Lightsail or these other services that are basically trying to make it so you don't have to do everything that I did to configure, they're trying to make it easy. They open up all kinds of things by default. Even I looked at the database migration service as an example, and it was like basically you tell me where your source is, you give me the IP address and a port and some credentials, and I'll pull that database in to a replication instance, and then I'll make that available in your VPC. And it started, when I did that, opening up all these rules automatically. I'm like, whoa, wait. I spent time making sure this was supposed to be a certain way. So that's my other concern, is that as Amazon tries to make services easier to use so they can make more money, and I mean, they should be easier to use, in the background, they're opening things up that could present security issues.
And so how do you feel about the control plane as well? I mean, Kubernetes is growing by leaps and bounds. And, my gut sense is that Kubernetes exposes the control plane directly out to the internet and has to be secured appropriately. Have you investigated that? Do you feel confident about putting a Kubernetes control plane layer over the top of these sorts of deployments?
That would be interesting. I've not really looked into Kubernetes or done the security research. I know Jay Beal has done a lot of research into the Kubernetes security, others as well. I have not yet. Certainly something I want to play around with. When it comes to managing secrets, I know in Kubernetes, it like base 64 encodes them or something wonky like that. I was like, that's not secure. And there's other issues. But I think Kubernetes is a similar kind of thing. Once you know it and you've tested it and you're more mature, you can create a resilient Kubernetes cluster in orchestration, right? But it's going to take you time to get there. Did that answer your question or not? I'm not sure.
Yeah, no, I think it does. I'm in the same boat. I'd like to spend a considerable amount of time with it when I have some time. Anyway, that's a whole different problem. But my gut tells me that sort of your data processing plane and microservices architecture, and Docker is one thing, and it has its own challenges. Your control plane being in software and orchestration potentially has bigger challenges to be overcome in terms of securing it, because it's the control, right? You want to make sure you get it right at both layers, and it'd be almost worse to get it wrong at the control plane, because that would obviate everything that you might have done at the data plane.
Yeah, it would negate all of those rules and policies that I'm putting in place, right?
Yeah.
Which is kind of scary. The other thing too, which is really the same thing. So I've done this in containers, largely because I pretty much had to, right? I mean, I couldn't see taking a PHP application and trying to find an Amazon service that would like run it for me and basically extrapolate away all of the container level. And it's like in the background for Lambda and these other services, they're running containers. But there's security and control kind of trade-offs, right? I did this in containers. If I were to do a Flask or a Node application, I could do it in containers, or I could go to Amazon services and build it as serverless architecture to run my code and utilize Amazon services. So we're looking at Amplify for running a Node app. I built these wonderful containers to run Node, and then Marston's like, no, we're just going to use Amazon service for that. And I'm like, well, that's an interesting trade-off, right? I do sacrifice some control, but maybe Amazon can do a better job of securing the Node architecture than I can build containers. I don't know. Maybe I want that control. The other thing containers give you is portability, right? So I can potentially take it to different providers or run it on premise without needing Amazon services. So
yeah, that's the biggest win. That's the hugest win. The fact that this architecture you can pick up and put anywhere,
right?
Potentially, I mean, maybe I'm an idealist, but I am very optimistic about the industry right now with this architecture in place. We've finally grown up to a point where we can treat these things as plug-in modules that do specific application layer tasks. We never had that before. It's a beautiful thing. I'm very excited.
Me too. I'm also excited to do the news. I will release my slides. We're working on a way to be able to release my slides and such. And if you're trying to build, especially MediaWiki, and you're listening to this right now, and trying to put in containers, definitely send me an email, and I will send you all of my scripts and Docker files and everything until I get that GitHub repository public. I just want to make sure I'm not leaking any secrets in my
he'll send you usernames and passwords too.
That's right. I want to change all my passwords, then make it public, so if something did slip in the history somewhere, it's not a valid credential. So.
What's critically important for me is that I fill up my drink right now.
Yes. Yep. Let's do that and cover the news. Take a short break and come back.